Hello, today we'll be talking about the Carcharodon carchias, aka the great white shark. For the first part, we'll be talking about the great white shark's connection to evolution and taxonomy. Early embryoc. Their skin color is a type of camouflage known as countershadowing. This makes them difficult to see. On your bottom left, you can see an early embryoc of the great white shark. Closely related organisms are the mako shark, porbeagle shark, and salmon shark. Fun fact, the megalodon is all common ancestor of all three of these sharks. This is a picture summing up of those two slides we just went over pretty much. Connection to genetics, biochemistry, energy. The great white shark gets its energy from stored fat oil in their massive livers, and they can swim nonstop up to 2,500 miles. Crazy! Food. Great white sharks eat sea lions, seals, small-toothed whales, otters, and sea turtles. Biochemical component. Their first dorsal fin shows its sharkiness. It keeps the shark from rolling uncontrollably. That's just a fun fact. Number of chromosomes. Sorry, gotta flip my page. The great white shark has 82 chromosomes, which is almost double the amount of humans have. We should all know this. Mr. Clayton taught us this very, very well. Environmental changes that have changed the shark genotype is climate crisis, wildlife, energy, and pollution. And then once again, this picture sums up those last few slides we just went over. Connection to ecology. They are located in many areas, such as South Africa, Australia, New Zealand, North Atlantic, Northeastern, and Pacific waters. They are located on the top of the food web and have a few threats in the ocean. Only orcas and larger sharks can face a threat to them. Symbiotic relationship. The great white shark has a symbiotic relationship with the remora fish. The remora fish eats deadly bacteria off the shark's skin. It also helps them from getting sick. One way humans have impacted them is by commercial shark finning because they use them for medicine and shark fin soup. And once again, this picture just sums up pretty much those last few slides we just went over. Connection to pathogen, which could be viruses, protists, fungi, and Parcarita. I can't pronounce that. My apologies. A type of sickness they can get is, I'm going to try to pronounce this to the best of my ability, Carobacterium maltaraxium. That was pretty bad. Which is a type of bacteria. This can cause brain and ear infections, which, as you can imagine, that's not very enjoyable. The cells in this sickness grow by aerobic respiration. Can't pronounce that either. And intracellular protons are consumed. This cannot be passed on to humans, luckily, so for anyone that's nervous, don't be. We're all good. And that's it. Thank you for your time. And hopefully I don't fail. And then here are the citations. Thank you, Mr. Clayton.